GCSE Physics boosters, work. We're going to do some work, learning about work. Now, this word work has a special meaning in physics. You know, are you doing work at the moment? Well, not really. In physics, work is done when the point of application of a force moves in the direction of the force. Now, that's a bit of a mouthful, but basically, if there's a force like this 300 newtons, and that force moves something, or it just moves, just the force moves, in this case 6 meters, then work is done. So if there's a force, if there's movement, you've got work. For example, the point of application of this 300 Newton force has moved 6 meters in the direction of the force. So this bloke has done 1,800 joules of work. Now, where did that come from? Well, work equals force times distance. Yes, work in joules equals force in newtons times distance in meters. And it's one of these equations you need to learn. Work equals force times distance. Measured in joules, so you can think of it as a type of energy. Think of work as being a type of energy. If you do an energy equation showing an energy transfer, then work can be in that equation. And if you're multiplying a force by a distance, you get a Newton meter. And a Newton meter, as long as they're in the same direction, is the same as a joule. A Newton meter is a joule. So work equals force times distance. Some interesting cases here. This bloke is falling. Energy is being transferred. Whenever energy is transferred, work is done. Now, the energy transfer is that gravitational potential energy is being lost. Kinetic energy is being gained. That is the energy transfer. Now, we could write work done by gravity goes to kinetic energy. So why? Because gravity is doing work. The force of gravity is mg, which is the weight, and then the bloke is falling a height h, so force times distance. You should remember that gravitational potential energy is mg delta h. So gravity is doing work. This person is gaining kinetic energy. Gravity is doing work. Here's an interesting one. This is a car traveling at a steady speed. Now, because it's traveling at a steady speed, it is not gaining kinetic energy. Kinetic energy does not come into our energy equation. Our energy equation is that work done by the engine, or if you like, you can say chemical potential energy if it's burning petrol, goes to work against friction. That's why the car isn't speeding up, because of friction. Friction is stopping it from speeding up. So work done by the engine is transferred into work against friction. Here's a very, very similar one here. This skier is going downhill at a steady speed. What energy transfer is taking place? And if you were listening a minute ago, you will know that the answer is in 3, 2, 1. There you go. Gravitational potential energy is transferred into work against friction, not kinetic energy. If they were speeding up, then it would be transferred into kinetic energy, but they're going at a steady speed, so work against friction. Whenever work is done against friction, heat is usually produced, and there is a rise in temperature. So this guy's starting a fire by rubbing some stick, twirling it around in his hand, trying to make fire. They say if you rub 2 sticks together, you can make fire. Well, you try it. It's not very easy. But the point is, whenever friction is involved, then there is a rise in temperature. Heat is produced. Yeah, energy is transferred into heat energy. Here are some questions for you to have a go at. I will show you my answers. So pen, paper, calculator, have a go at them. I'll show you my answers in 3, 2, 1. And there you go. So the first one, straightforward, force times distance. The second one, top right, I've had to rearrange the equation because I'm working out the force. Okay, the friction force is slowing down the car. And if we assume that the friction force is constant, which it won't be, by the way, but if we assume it's constant, then the friction force is the change in kinetic energy, or the work done by friction, which is the same, divided by the distance, so we get 900 newtons. The bottom left one is this: somebody working against gravity. You know, what force do they need to lift 200 kilograms? Well, that would be 2,000 newtons. And then 2,000 newtons times the height of 2 meters gives you 4,000 joules. And then the bottom right one is this idea that the kinetic energy of the car is transferred into heat energy when the friction force acts on the brake pads. When friction is involved, you get heat energy, you get a rise in temperature. Just rub your hands together now. See what happens. Last little question to get your brain working. Now, the force of gravity acting on this satellite keeps it in orbit. Is this force doing any work? Is energy being transferred? And the answer is no. Why? Because the movement of the satellite isn't in the direction of the force. It's at right angles to it. There is no movement in the direction of the force. So this force doesn't do any work. It just changes the direction of motion. We'll do orbits later, much later. When we do space, we'll do that topic in a while.